Hello everyone, I am Ryan Glukowski with 4D Systems, and this is the first in our NX webinar series. In this webinar, we will be taking a look at some of the features in the different NX CAD Mach packages, as well as showing a demo of the NX Mach Advantage features. First, a few things about 4D Systems. 4D Systems is a premier provider of Siemens PLM and robotic simulation software. Our team of engineers bring together decades of experience in product lifecycle management, solution implementation, simulation, engineering, and manufacturing. Our focus on customer satisfaction allows our clients to gain an edge in an increasingly competitive market. We enable our customers to improve their productivity and profitability by delivering and maintaining world-class PLM solutions. As a leading software and service provider, 4D Systems works with Fortune 500 companies in North America to help them exceed their goals. So as well as being a software company, we're a full service company, from software sales to on-site engineering support and full turnkey robotic systems. This allows us to have a unique position in the marketplace, seeing the impact of our PLM software directly onto our own products as industrial robotics suppliers. Here I have some info about myself. I'm the mechanical designer for 4D Systems, as well as a pre-sales technical support for Siemens NX products. I've worked in aerospace and industrial robotics, and have had experiences from assembly on the shop floor, to quality work for a major aerospace engine supplier, to designing tools and products for repair and robotics. Along the way, I have amassed years of experience with Siemens CAD and CAM products. So I've witnessed experience how digital technology transfers to the real world production, and I'm here to share my insights with you. Here we have the info on NX Mach packaging. So NX has offered a number of tiers. These tiers are broken down into Mach packages. So basically it goes from Mach 1 to Mach 3 with Mach Advantage below 1, and with some other specialty packages mixed in as well to better suit some specialty purchasers. So NX Mach software products are prepackaged solutions delivering high-performance CAD capabilities of NX software, the leading solution for mechanical design. They offer competitively priced solutions tailored to specific product development roles, practices, and processes in 4 performance tiers. Value-added upgrades are available to move customers from one tier to the next. Each package delivers complete capabilities for production work. So in this webinar, we will be reviewing the capabilities of NX Mach Advantage, the lowest tier, through a pre-tape demo, as well as reviewing different features available to you as you climb the Mach product ladder in a presentation. So first off, we have NX Mach Advantage. So Siemens offers NX packages at multiple price ranges to suit a broad range of customer needs. So the lowest cost option is NX Mach Advantage. This package is a great option for customers that seek powerful NX modeling, assemblies, and drafting tools at an affordable price. So now we're going to do a short demo reviewing the capabilities of NX Mach Advantage. Okay, I have opened NX, and here we have the NX user interface. So here you can see the quick access toolbar on top, where you can access often used tasks such as saving. The ribbon bar directly underneath is similar to modern Microsoft products, where common tasks are grouped into tabs pertaining to each activity. On the left side here, we have the resource bar. The resource bar allows you to navigate information on the current part. So here we have the assembly navigator open, but we can also open things like the part navigator. On each of these bars can be customized to suit each user's needs, and you can save these preferences under your user roles. So to start, we'll be putting together an assembly to show off the ease of assembly constraints, and as well the ability to model in the assembly context. So we're going to start by modeling a CPU heatsink assembly with a contact block, a heatsink array, a fan, and we're going to be modeling a shroud within the context of the assembly. So to start, we're going to add a base component. This will be the contact block. So I'm going to go ahead and add a component. We're going to open to our folder structure. I'm going to go to my desktop, and I have all the parts I need here. So to start, I'm going to use the CPU plate. And here you'll see the part selected. and you can move or constrain the feature, but we're just going to go ahead and hit OK. And because this is the first part in our assembly, it's going to ask us if we want to create a fixed constraint. In this case, we're going to select yes, and this locks the context of the block in place. And then we'll use the assembly constraints to constrain the other components in reference to this fixed component. So we're going to hit yes there. And here, in the assembly navigator, we can see right here is on the position, the constraint, it's noted as fixed constraint. So now this part cannot be moved. So next we're going to be adding the heatsink component. I'm going to do the same thing. I'm going to add a component. I'm going to browse to my desktop, and I'm going to add the heatsink. And here you can see a preview of your part to make sure you've selected the correct part. So I'm going to open that, and here you can see it's overlapping our other component in an unsatisfactory way. So we're going to constrain this component. So first I'm going to do is I'm going to move this component off the face of my block to give me some more room to see what's going to happen for my constraints here. So now we can do one of two things. We can constrain directly in this add component dialog. I'm just going to go ahead and hit OK, and I'm going to go back to assembly constraints here. And now we're going to use the touch constraint, and we're going to touch the bottom face of this heatsink array to the top face of the CPU block. And you can see there the NX has automatically moved the part to be in contact directly with the top of the CPU plate. Now I'm going to do concentric constraints. Concentric constraints are great because they actually do two constraints in one. They constrain you for moving in X and Y axis. Essentially, if you're looking in these directions, it keeps you within the circles from touching each other. So now I'm going to go ahead and hit OK and apply that constraint. And we're going to see, let's say we're curious to see how our part is constrained. Like, where can it still move? We want to get it fully constrained so it can't move in reference to the fixed component. So I'm going to go ahead and click on the part and show degrees of freedom. So you can see here it's showing that we have degree of freedom around the axis of the hole in a circular fashion. So we need to constrain the part from moving in that direction as well. So I'm going to go ahead and I'm going to make another constraint. Same way, concentric, and hit OK. And here, now, if we go ahead and try to move the component, so we can hit move component, select the heatsink, and we're going to do a dynamic. We can drag this component in any direction we'd like, and we note that it's not going to move, and that's perfect. So I'm going to cancel that and discard the changes. So now, in the assembly navigator, you can see that this part is now fully constrained in reference to our fixed Demo 1 CPU plate. So next we're going to be adding the fan. So the fan I've gotten is a purchased component, so just a generic fan that you can purchase. And it was a step file that was provided by the fan manufacturer, and we're able to take that purchased component step file and directly import it into NX. So here you can see the previewed component, and it brought in the fan. The fan is actually an assembly. You can see here in the assembly navigator, it's an assembly of multiple features, and it brought it in as one sub-assembly. So we're going to go ahead and move this to make sure it's correctly oriented. Okay. So now it's out here, and we know that the intake goes from the open face to the face with the strut supports on it. So we're going to go ahead and move it so we have it pushing the air in the direction we would like it to. I'm going to move it at an angle here and slightly down so it's close to where we want to constrain. I'm going to hit OK. So now we're going to constrain this part similarly to how we did the other one. We're going to use a center constraint in this case to center it. And we're going to do that here. And I'm going to use the two outside faces here and here, and then the two outside faces of the heatsink, and it's going to center the component this direction. So now I'm going to touch the component to the actual side of the heatsink here. You can pick any one of the fins. And finally, I'm going to go ahead and drag this component down so it's below the top of the heatsink. There we go. And now I'm going to put a distance constraint on there. So the distance constraint can be modified later. So I can set my distance, and my distance I want to set is going to be, let's start with 2.5 millimeters. Oops, I made a typing mistake there, no problem. It error checks me and puts me right back on track. Okay, so I'm going to go ahead and save the component. And now you can see the fan is also fully constrained, and you have the sub-assemblies here, fan form and the fan itself, also in context of the assembly. Okay, and now we're going to show off the in-assembly modeling function of NX. So we're going to go ahead and double-click on this heatsink component. We want to make this the work part. Oh, sorry, click on the component in the assembly navigator. And we want to wavelink the face of the fan. So what the wavelinker does is it projects the faces or solid bodies, you can select different options here, of a component in the assembly with your current work part. So we're working within the context of the heatsink, and then we're going to take the wavelength geometry of the fan in the assembly and bring it into our part. So here you can see it actually hides the original part, and we've brought it in to the heatsink. So now if we go to the part navigator, which is our individual part feature navigator, we see that we have the linked face as an option. And what I'm going to go ahead and do now is I'm going to use an extrude feature. I'm going to select the circles that I've just wavelinked. And you should be able to select all of them at once. Okay. And we're going to specify our vector, and I want to do no Boolean to start just so I can see my preview. We can reverse the direction, and we can select until extended on this face, and it'll stop the holes right there in this face. Oops. And now I'm going to go ahead and subtract from the heatsink, and you will see we now have 4 properly placed holes here. Oops. Apologize for that. So now you can see we've essentially placed the holes in context of the fan, and they match up perfectly with the fan. So now that's completed, I can go ahead and go back and double click on the actual assembly, and you see that the fan shroud is actually hidden right now, or the fan case rather. So I'm going to go ahead and show all my geometry, and we'll bring it back into the context. And just to show that these parts are truly linked together, I'm going to go ahead and actually bring in or change the constraint, the distance constraint we made right here. I'm going to go ahead and change that to 5 millimeters. Hit OK. You can see the fan moves down, and also the holes move down. So these holes are now linked directly to the fan, and any changes that I make to the fan's position within context of the heatsink automatically gets updated to the heatsink holes that are wave-linked to the fan face there. So that's a great feature for NX's in-context assemblies. It's very easy to link these things together, make quick changes that don't affect your entire part history. So you don't have to go back, go into the drawing for the heatsink, change the hole position, check it against the fan. You know that it's going to be directly connected to the fan. It's going to change directly with all your other assembly components that you link together. Okay, I'm going to go ahead and save that part again. So finally, we're going to add a brand new component here into NX. So we're going to show you how to model completely new components within the context of the assembly very quickly. So what I'm going to go ahead and do is just create a new component. It's going to be a millimeter model. It's going to be on a desktop. That's perfectly fine. And we're going to go ahead and call it Demo 1 Shroud. So this is going to be a fan shroud to direct the air. Maybe you have a selected air path you want to keep. We're going to keep that in the air path of the heat sink. So here we go. We're correctly named. Go ahead and save it. When you create a new component, you can select components within that already in your assembly. It's going to be a brand new one, so we're just hit OK with 0 components selected, and it's still going to create the component here. And you can see it's not constrained yet, and it's here in the assembly navigator, and if you double click on it, it has no parts. It's just got a date and coordinate system, right? So what we're going to do, similar to how we did the holes, we're going to do the wave geometry linker. And I'm going to go ahead and select the other face of the fan to link. And then now we're going to make a datum plane. And we're going to do it at a distance from the face we created. So we have 50 millimeters. And this is where we're going to put the front of our shroud. The back of our shroud is going to be the exact same dimensions of the fan to make sure we have a perfect fit. And we're going to create a sketch on this datum plane. And we're going to put a circle in here. And actually, I want to project the center of this other circle with the linked face we have. So we have a center point to constrain our circle to make sure it stays in context of the fan, the same orientation. Go ahead and create a circle, and we're going to change this dimension to, let's say 70 millimeters. Perfect. Okay, now finish the sketch out, and you can see we now have a circle here in the sketch, and we have the geometry of the face of the fan. And what I want to do is create a smoothly contoured surface that matches those two shapes into a shroud that will fit nicely on this fan. So to start, we're going to select the circle. We're going to add a new set, and this is through curves, so this is making a nice through body surface here. I'm going to select the edge of the linked face. Oh, unfortunately, I only selected one curve. We want to select all the connected curves on the outside of this face, and that's perfect. And we're going to show the preview, and that should be perfectly fine. Okay. Oh, I selected the wrong part. Sorry about that. Go through again. Here's through curves. That's the proper one. And again, we're going to do the same thing. Add a new set. We're going to select this. And here you can see it created a solid body that matches the back face of the fan with their circle that we've created. So we're going to hit OK. And it is a solid body, so we do want to actually shell it out, which is really easy. Shell. We're going to remove the top or the bottom face and the top face here, and we're going to make a 2 millimeter shell and hit OK. And there you can see it's made a thin wall shell that matches the contour of the sketch we made with the contour of the actual fan shroud. And now we're going to go back to our assembly, and we're going to show the fan again. And let's go ahead and change this distance right back to 2.5 millimeters again, just for consistency's sake. And you can see the fan moves, and it actually regenerates the surface that we've created here and makes it in the same context of the fan. So you can move this fan anywhere you want, and you're going to have the shroud matching perfectly with it and the holes matching perfectly with it. So hopefully that shows some of the features that are useful within NX, especially some of this in-context, wave geometry linked, really fast and easy ways to make parts in context with each other and have them be able to be moved without being broken and creating a bunch of rework. So this is going to save you a lot of time when you're initially modeling, and also on the back end if you have to make some small design changes. We all know how one small design change can create a huge mess. With this, it will not. You'll have all your features constrained properly. Do a quick change, won't even affect you. You move on, and you're done with the design there. So NX is a very powerful tool, and this is some of the features that are available in its lowest priced NX Mach Advantage package. Let's go on back to the PowerPoint. All right, so hopefully that demo showcased some of the capabilities of NX. So here are the actual package contents for NX Mach Advantage. So we have solid feature modeling, so that's your basic modeling with your features such as extrudes, holes, all the We have assembly modeling, which we saw in that demo. We have design logic. We have grip runtime, which allows for macro use to streamline things that you do quite often in NX. You have translators. You have IGES, DWG, and other AutoCAD files, STEP 203 and 214s, and 2D Exchange. So with these translators, you can take files from your customers. You can send them out to other people that require different file systems, and you can import stuff from catalogs and stuff. So almost all online catalogs will have one of these options for you to import, and it's a very powerful tool to allow you to do a lot of quick work without having to model a lot of things by yourself if you have to buy, get those purchase components in there. You have your freeform modeling, so that's some of the surface stuff that we showed. We have a straight break sheet metal tool that allows you to show metal bends and do a flattening of them. And then we have drafting tools as well. And that's all in an NX Mach Advantage package. So it's a great package for a low-cost entry into NX. Moving up the rung one step, we have NX Mach Designer and Mach 1 Design. So these two packages are pretty much identical, with the one thing being different between Mach Designer and Mach 1 is Team Center integration. So with these two packages, you get Express Review, which allows for export of simplified documents to a free viewer. So if you need to show an executive something in 3D space, you can ask them to download this simple viewer for free, and you can send out these files and have them review them. It's great to send to people that don't necessarily have a full NX seat that need to see these 3D tools. Knowledge Fusion Runtime, that allows for some more advanced Java, C++ programming integration. Process Studio Runtime allows for simulation processes to be saved and wizards created. So this allows you, if you're doing simulation quite often, you can save a wizard with the common inputs you need, and it'll be easier for other users to do that as well. Rapid Prototyping allows for modification of 3D scan files and creation of simple 3D parts. Web Express, and also process solutions for stress and vibration. So that's basic FEA simulation solutions for stress and vibration. And finally, the Team Center integration, which comes with the Mach 1 package, that allows for, that's very powerful PLM integration. So it allows for server-based product lifecycle management. So that's a great addition if you have multiple users or you're trying to future-proof yourself as far as maintaining the products you design all the way through its life cycle. Finally, we have next rung, which is NX Mach 2 Advanced Design. So that adds flexible PCB, so PCB design. That adds product validation, which is automated design checking tools. That adds 3D annotations, so GD&T and PMI within the 3D space, which are becoming more and more popular now to go with sort of a paperless, paperless sort of business model. If with the 3D models with direct PMI integration, you can actually save all your dimensions in the 3D space and easily export them to a actual drafting 2D sheet as well, if that's what you need. There's user-defined features, so those are features you can save within a library and reuse in multiple different parts. If you have repetitive part features you like to add multiple times. There's dynamic and photorealistic rendering, which is great for product pages, help manuals, websites, to make really nice renders that look photorealistic. Also routing, so mechanical routing, so it's plumbing parts, other stuff like that. That's all part of the Mach 2 Advanced Design package. So some really powerful tools to move up the rungs. Finally, the top tier rung we have is NX Mach 3 product design. So it has everything, everything mentioned before, as do the other rungs. They have everything mentioned before, plus all these. These have advanced assemblies, so larger scale assemblies, freeform modeling advanced, so that's some more advanced surfacing tools for A-class features. We have Optimization Wizard, which is automated design optimization for weight, size, volume, other things as well. There's molded part validation. It's an automated tool for checking your molded part for actual feasibility. There's Freeform Shape, which again is more advanced freeform surfacing tools. And then there's Advanced Surface Analysis, which is a check and optimization for surfacing. So as you move up the rungs, you get a lot more tools to help you really pin down your design and make it more automated to do design checking as well. So finally, there is some other packaging options as well. So these kind of fall outside the niche of Mach 1, 2, or 3, but are still, if you need some of these features, they're really helpful to have. So we have NX Cool Shape. So that's sort of more on the industrial design and styling section, where it has the advanced freeform shape with some of the less of the feature modeling stuff. There's NX Mach 3 industrial design, so that combines Mach 3 with the cool shape, so you get Mach 3 and all the advanced freeform shape dialogues there. We have simulation options. We have Mach 2 advanced FEM, so that has all the Mach 2 features, but it includes NX Nastran simulation, which is really powerful simulation software for very complex FEA solutions. We have NX Mach 3 advanced simulation, so that's Mach 3 with the NX Nastran package as well. So that's pretty much all the bells and whistles you can have. And then finally, we have 2 tooling design options with Mach 3 mold design and Mach 3 progressive die design. So if you're in the mold or die business, those 2 tools are really powerful to allow you to have all that mold and die checking built into your tools, as well as having all the feature and assembly modeling that Mach 3 offers. I've been Ryan Legowski with 4D Systems. Thank you for your time.